Yes, you saw that correct. We are in part 2 of the Matrix trilogy. This is Rockswold 6.4b. We are continuing to do solutions to linear systems of equations using matrices. So in this section, if you felt like the last section was tedious, you might enjoy this section a little bit more, because in this section, we're going to start using technology to start solving these systems of linear equations. And so we're reading this first problem. This first problem says when three pumps A, B, and C are running together, they can pump 2,900 gallons per hour. When only A and B are running, they can pump 2,200 gallons per hour. And when B and C are running, they pump 2,100 gallons per hour. So what is the pumping capacity of each pump? So I want you to think about this for a minute. I want you to set this thing up. With a series of equations. So what variables are you going to do? How are you going to define your variables? And so what I went with was A, B, and C. So A is the gallons per hour pumped by pump A, right? And same thing with B. I'm going to be a little bit lazy and not like keep writing the same thing over and over and again. Okay, so the first thing it gives us is that when all these pumps are combined, A, B, and C, they're going to pump 2,900 gallons per hour. And so if A pumps this many A gallons per hour, B pumps B gallons per hour, and C pumps C gallons per hour, this equation probably should look something like we're combining those rates together. They're working together, and they're working together to pump out a rate of 2,900. So this is my first equation. The next equation says A and B pump 2,200. A little bit like A plus B. Maybe a little weird. Just so the spacing is kind of the same. And I can put these, it'll be a little bit easier when I go to put these into a matrix if I space them correctly. And so if I do A plus B, write my A's under my A's, my B's under my B's, my constants under my constants, right? And then the next thing, it says B and C work together for 21. Here we go. We have our equation. And so we want to put this thing into a matrix. So I'm tempted to write things here, but I really think you should start like seeing these things, start seeing them filled out, or if you don't, or if you still need to write them, go ahead and write them on your own, right? But like I'm going to start dropping writing these things. If you write them, I don't care. I'm not going to count off for it, right? But I'm going to start dropping it in my work. So this has a coefficient of 1, and so that's what I'm talking about. I'm not going to write it there. But this is 1, 1, 1. Have my equal sign, and it says what, 2,900. So that's the first line. Close off my matrix. A plus B is 2,200, so 1A, 1B. I should write something here. There are no C's there. I should write a 0 there. And so that's another thing I'm talking about. I'm not going to write it. I'm just going to kind of plug it in, right? And this should give me 2,200. Okay, last one. I don't have an A, but I have a B and C working together to give me 2,100. And so if you want to solve this by hand, this one I don't think it's too difficult to solve by hand. Okay, so what I ended up doing is I kept the first row 1, 1. I did row 1 minus row 2. So I know minus it. Row 1 minus row 2 and row 1. And so that will give you solutions pretty quick on this one. I know I'm not doing it in maybe the way that we did row echelon form previously with the Gauss-Jordan elimination, but it works for this one. If we look at these equations, I think even if you look at these equations, right, we're taking A, B, and C together. If we subtract A, B, and C from A and B, we're going to get just C. So the thing that's like difference between these two things is probably going to be your C, right? And so I think if you can do these without doing a matrix, bravo to you. But we're going to go ahead and do these right quick. So if I do row 1 minus row 2, this is sort of like I was saying, 1 minus 1, 0, 1 minus 1, 0. It's going to give me 0, 0. It's going to give me 1C right over here. And then I'm going to do the 29 minus the 22 is going to give me 700. If I do the same thing for row 1 minus row 3, right, row 3 over here, row 1 minus row 3, 1, 1, 1 minus 0. And then I do 2900 minus 2100 is going to give me 8. And if I have this equation, I can go back and write this. If I have this matrix, I can go back and write the equation. So 1, 1, 1 looks like A plus B plus C is equal to 2900. This thing looks like we already got it solved for. This is C is 700. This is A is 800. And so I already have 2 of them solved. I just need to solve for which one? B. So if I solve for B, that's not too bad. Plus 7 plus B plus 700 is 2900. So I believe what? B plus 1500 would give me 2900. So if I subtract 1500, B should be 1400. That's it. So if we want to go back and interpret these things, where am I? So A is 1800. So pump A. I should go back and write them a sentence. So typically, if we were solving these things, we would go back and write a, we would go back and write the ordered triplet, right? Or ordered triple. And so we're solving a math equation. That makes a lot of sense to write the ordered triple. But here they're asking a question, right? How much did pump A pump? How much did pump B pump? How much did pump C pump? So write them in English sentence, like in return, right? They're asking you a statement in English, write them a response in English. So pump B pumps 14, so it probably makes sense why they had it running for so long on all of those equations. Pump A, pump B, pump C. And I'm getting lazy, so do as I say, not as I do, probably. So pumps, what are we doing? C was 700, that's it. Okay. So going back to, where's my original matrix? Going back to this equation, I want to show you how to do it on some technology. So if I want to do a screen share, I have to share the screen. I have to bring up my 84. Okay, what did I got showing here? I want to clear this out. So I've cleared my TI-84. So this should work on pretty much anything like an 82, 83, 84. If we want to put in a matrix, you might notice there is a matrix button right here. So if I hit second and second and this exponent, this negative exponent, that's the matrix key. So if I want to put in a matrix, these are the names to recall the matrix. So these are sort of like variables that represent the matrix. This is math we can do with the matrix. But if I want to put it in, I have to go on over here to edit. So I go to second, I hit that matrix key. If I want to put it in, I have to edit it. Now they're asking for the dimensions of this matrix. So we're going rows by columns, all RC soda. So rows by columns, there are 3 rows by 4 columns. So now I want to put in that matrix. So I go 1, 1, 1, 2900. I go 1, 1, 0, and I do 2200. I do 0, 1, 1, 2100, 100. There we go. And I have my matrix. I've put in my matrix. I don't want to edit my matrix anymore, so I have to quit out of this. So I hit second, and I quit. Now, second matrix, and I want to do some operations with this matrix. I want to get this thing down to echelon form. I want to do some Gauss-Jordan elimination. So if we're looking through here, and there's a few things, that's what cumulative sum, REF. I see RREF. So this is reduced echelon form. This is row reduced echelon form. So let's go and see. We've done row echelon form. So let's try this out right quick. So if we do row echelon form, I want to do row echelon form on my matrix. So I hit second matrix, and I want to recall the matrix. It's in here. So if I want to recall the matrix, this is like the variable for the matrix, right? So if I want to do reduced echelon form on A, this is how I do it in the calculator, which is okay. But we have a calculator, and we saw this other option on here that looks like RREF, right? And if we do this on our matrix, so we hit RREF, we hit second matrix again to call up the matrix. We hit the matrix that's in the names. We want to do row reduced echelon form on our matrix. That gives us our A, that gives us our B, that gives us our C right off the bat. So maybe like taking note of what the difference is between row echelon form and reduced row echelon form. So row echelon form can have other numbers up in these areas, right? It has the ones in the diagonal, has the zeros below it, but it can have other numbers up in here. And we have to do like some back plugging and solving to do, if we want to do row echelon form. If you have the technology, I don't know what to tell you, but like use it, right? Use it to your advantage. We can jump right to row reduced echelon form. That's what I would do. It gives you A, it gives you B, it gives you C. If you want to look at your matrix, you can also just recall up the original matrix. And so sometimes when you're inputting your matrix, depending how your calculator is, you may or may not be able to see your whole matrix. But if you do this sort of thing, you can always kind of sort of recall it up, and you can look at the whole matrix all in one screen, right? And so sometimes this helps. This is expandable. Playing with this thing a little bit. Okay. So stop the share. Let's go back to the assignment. So before we go to the next page, I want to talk a little bit about like what our solutions look like. If we have like a single variable equation, like x equals 6, we could plot that as like a point on a number line, right? So this has like no dimensions. If we have something like x plus y equals 6, then we would have to draw an x and y axis, and it would look something like a line. So these are sort of like what our solutions are looking like, right? So if we have a single variable, it looks sort of like a point. If we have two variables, it looks like a line. So we're going from a point to a line. And then the next thing that goes from point to line is that we got to talk about a plane, right? And so solutions with three variables are going to look like planes. And so there's a few ways that when we talk about solutions, and again, solutions are where these things intersect. And so if we're talking about where these things intersect, there's a few ways planes can intersect. And so we have seen this thing. If we have one solution, so this is like the previous problem where we have one solution. It's a single point. You can give me a number for an x, a y, and a z. Okay, so this is going to happen sometimes. Probably not very often, but like I have an x, a y, I have a z that goes in and out of my paper, right? And I think if you think about just the zero planes, zero. So if I think about the x equals 0 plane, that's the plane happening right everywhere where x is 0. Quantity. So that's that plane that's kind of coming in and out of the paper. The y equals 0 plane is everywhere that my y is 0, so that's everywhere. Right here, x and z. But my y is already 0, so that's the flat thing coming in out of the paper. And then I have my z equals 0, which is the plane, which is my x and y plane. And so if I'm thinking about all these three planes, they're going to meet at exactly one spot, and that spot's going to be, which is like our origin in 3 space. So maybe the 0 planes might be like a good example to get at a sort of simplified example of where 3 planes intersect, right? So they don't always have to be right angles. They don't always have to be sort of orthogonal to each other. They could be like this, and it looks like there is a single point. So we're trying to do some 3D models on some 2D paper, but this is coming in and out of the paper, right? This is coming in and out of the paper that way. And so they could intersect at exactly one point. That's one way that planes can intersect. That would be what? Consistent, I believe. There's this other thing where maybe they don't meet, right? And so there are these sort of like what you would call parallel planes. They're planes on top of each other. And so these things are never going to meet. So they could be parallel. Another way is that they could be like, what do we call this? They can never meet at a single point. So if we look at this plane, it's going to extend this way. This plane is extending this way, and this plane is extending this way. Those 3 are never going to meet at a single point. And so they give you this sort of thing. And so if we get a system, well, they're giving you what the reduced echelon form looks like, right? And so if we do reduced echelon form and we end up getting nothing but zeros, and then we get some number over here. So this last line in our matrix should look something like, you can give me a number, any number, I don't know, 8. Something that looks like 0 equals 8 in that last line of our matrix, right? This looks like a contradiction, which should give you no solution, right? And so hopefully these things are matching up to these sorts of solutions that we got when we had one variable and two variables, right? And so hopefully these kind of are, I want to say synonymous, but correlating to those things, right? So if there's any number here that is not 0, right, we're going to get 0 equals a number, which is a contradiction. These three planes are never meeting is what is happening graphically. The next thing, if we get something like 0 equals 0, is what this last line of the matrix is giving me. If we get something like 0 equals 0, previously that would be implemented. And when we're in 2 space, it looks like a line in 2 space. When we're in 3 space, you might notice all they're intersecting. We want to continue all of them. And so this is going to look like a line in 3 space. And so in a minute, we're going to talk about how to talk about a line in 3 space. It is not the same way we're going to define a line in 2 space. It's a little bit different. It's got its own little challenges. But it is doable, and we can talk about it in just a second when we get there. But these are the sorts of solutions you can have. You can have one solution, and this is like our row reduced echelon form, just like the things we've been solving, right? You give me a number for an x, you give me a number for y, you give me a number for z. You could have no solutions, so you should not be giving me anything besides telling me no solution. You should not give me any numbers besides maybe this thing that is a contradiction, right? So write this thing out, tell me it's a contradiction, tell me no solution. This thing, there's infinitely many solutions. They look like a line. We'll talk about how to write a line in 3 space in just a second. So let's do this again. We have this thing, and we want to classify and determine the number of solutions. So we're looking at this. We're supposed to have ones in the diagonals. Uh-oh, something went awry because we didn't pick that. What does this last line look like? This last line looks like a 0 line. So the second you see that, I want it like your brain to snap. What does that mean? What does that mean? What does that mean? What does that mean? If you told me there should be infinitely many solutions, identity. Absolutely correct. So we want to go back. We want to write these things. This is like x. This is like my y. This is like my z. So to recap, we did a word problem. I think from now on, we're just doing x, y's, and z's. So we don't have to worry about going back and interpreting and things like that. So we'll stick with the x, y's, and z's. So this looks like x minus 2y. And I have another one. Ooh, what's my z there? I have another one that looks like y plus 5z equals 2. And so this has infinitely many solutions, but it's not just any and every solution out there, right? It's not any and every solution out in space, out in 3D space. And so we're looking at this thing, and it looks like a line, but it looks like a line in 3 space. So we want to write a line that has 3 different components, x, y, and z. And so to start this off, this thing is consistent. We're going to define things in terms of z, is the way that we write this line. And so we start off, I don't know what my x is, I don't know what my y is. but I know it's z. And so now I want to solve for these other things. So I'm going to solve for y first. And so I look at y plus 5z. And I want to solve for y. So I'm solving for y. In order to solve for y, I have to subtract 5z over. So if I subtract the 5z over, that becomes negative, and that 2 is still positive. Still know what my x is, but I know my y looks like minus 5z plus z. I still need my x. So going back to that equation with the x, it looks like x minus 4. So maybe it's worth noting, but this was not in row reduced echelon form, and if you're doing things in your calculator, typically you'll save a little bit of work. We're doing maybe a little bit of more work on this one, just because of how they gave us the matrix, but it's still doable. So let's look at this. This is x minus 2y minus 8z. We don't want that y in there anymore. So if we look at y is a minus 5z plus 2. This looks like minus 2 minus 5z plus 2 minus 8z, and this is equal to minus 4. So we want to solve x in terms of z. So we got to do some distribution. X equals minus. So I can combine some like terms. X plus 2z minus 4 equals a minus 4. If I add 4, x plus 2z equals 0. Okay, so that is important to write that over there. So don't drop that. We're adding 4 to each side. We want to solve for x in terms of z. I got to subtract. So going and recapping this thing, this looks like minus 2z. This looks like minus 5z plus 2. And this thing looks like z. Okay, so maybe a little bit to note on this. This is what a line looks like in 3 space, and that's the best sort of explanation I can give. You might notice this is a linear sort of pattern happening here. This is a linear sort of pattern happening here. So if I think about my x and y plane and I add the z plane in there, this is happening between the z and the x. So between the z and the x plane, there is some sort of linear pattern happening here, right? And so maybe let me draw a line in 3 space. I don't know, it's coming from here to here. And again, I'm like trying to draw something that's 3D on a 2D surface. So it's a bit hard to do without going all out with something like this, right? If I'm looking between x and z and I hold the y constant, you might notice there is just like a line happening between here. And this is a sort of like, you know, a 2D projection of a 3D line. It's essentially what's happening right here. If we hold, what is this? Y constant, this is x's and z's. So if we're just looking at this flat plane right here, and we didn't look like this, we weren't paying attention to whether this line was going up and down, it would make a line, right? Same thing with this. If we were looking at what? Our y's and z's, our y's and z's. So now this plane coming in and out like this, right? If we were looking at this line, it would form just sort of a linear sort of pattern happening there. And so if we put those two planes and those two projections together, we will get the 3D line. So you can think of this as like different, what do they call them? Like orthogonal views, I believe is the word they use for those, right? It's sort of like that thing happening. We have these two different views of a line, and when we put them together, we get a 3D line happening. Okay. So it's probably not so much important that you can go and graph these in a 3D space, right? I obviously can't go and graph these in some sort of 3D space. So that's not something that's going to be highly looked at for you to do, but you should be able to like go to this problem, and you should be able to write out these equations, and you should be able to solve them for terms of z. And again, this one might have made itself a little more difficult than if you're actually using a calculator to do this work on your own, right? Because this is not row reduced echelon form. If these were nothing but zeros up here, this would be a lot easier to solve. But that's not what they gave us, so we went with what they gave us, right? All right, next page. We have a few more matrices to work through. I think we got 3 more, to be honest, right? 3, 4, we got 4 more. Okay, so a little bit about what I expect. You can use technology on these if you want, but if you're going to use technology, what I expect, and you might want to like make sure Miss Watson, Miss Watson's expectations are the same before you go assuming things, right? But what I personally expect is to plug this thing into a matrix. I want to see the matrix that you plugged in. So 2, 5, 1, 1, 2, minus 1, 2, 3, 7. Oh, there's no z's. That might be a little bit of a doozy. But we can plug in those zeros if we don't see the variable. And so this is what your matrix should look like from these equations. So I want to see this work if you're doing something. The next thing that I want to see if you're doing this, let's do screen share. Smart view, let's do this. I want to see, well, let's do it right quick and I'll go back to that page. So let's go plug it into the calculator. I'm still doing a 3 by 4 matrix, so 2, 5, 1, 8. 1, 2, -1. Make sure you hit the negative and not the minus sign, right? If your calculator will give you an error if you got a TI and you hit the negative instead of the minus. It makes a weird distinction, and I'm not sure why it does that, other than it's probably built into the programming somewhere, right? 3, 7, 0, and 5. So I have this thing in my matrix. I don't want to mess with it anymore. I hit second and quit. I want to do second, hit matrix again. I want to do some mathematics with this matrix. I want to do row reduced echelon form, which I believe is option B. I want to do row reduced echelon form on second matrix, on matrix A, which is right there. I hit enter, and it gives me this matrix. So what I want to see, you'll see it in a minute. Copy this thing. So minus 1. Stop out of that screen share and show you what I got written down. So I want to see the matrix that you plug into your calculator. I want to see this matrix that comes out of your calculator. That should be the bare minimum of what you show, right? If you show any less, you're going to get points off. You can say something, maybe I plugged it into a calculator. That's fine. So at least show me the thing that you plugged in and show me the thing it spit out. if we see this, oh man, we see this? What do you notice? This is supposed to be row reduced echelon form. Oh, why the heck is it still throwing me numbers up in here? Huh. Well, we look at the ones in the diagonal. 1, 1. Oh, we didn't get a 1 here. What is this last line telling me? So go back and interpret this line and what it says and tell me what the solutions are. So this tells me 0 equals 1. That tells me there are no solutions because that is a contradiction. There are no ways these three planes are going to intersect. That's what that is saying. Okay. So we had one that was what, a line, we had one that was a no solution. Now we'll have a few more, 3 more. So you should be able to plug these into a matrix. You should be able to write the matrix. You should be able to plug it in, hopefully have some sort of technology to plug it into. Okay, so let's start with number 4. The matrix for number 4 is what? -1, -3, 2. I draw my bar. I got 14. -1, 2, -3, -6, 3, -1, 4, -2. All right. So hopefully you have that. Hopefully you've already plugged that into your calculator. If you plug that into your calculator, what is that going to spit out? Okay. So if we plug this into our calculator, we should be getting back out 1, 0, 1, -2, 0, 1, -1, -4, and 0, 0, 0, 0. Now we're looking at this thing. I plugged this into my calculator. I did row reduced echelon form, and it spit me out this thing. Now I want to look at this. What is this last line telling me? This is giving me something like 0 equals 0. And the second that you see this, I want you to think infinitely many. All right. Infinitely many, it looks like a line. I got to give you a line. So in order to give you a line, I got to go look at these equations. So this says x plus z is equal to -2. This next one says y minus z is equal to -4. So that is going back, writing our matrix and writing back the equations. So I have these guys. I want to write a line in 3 space. I want to write something that is in the form x, y, z. And I want to write everything in terms of z. So z is there. It is done already. So I want to write y in terms of z. So if I do y minus z equals to -4, and I want to solve for y by itself, I have to move the z over. So y equals positive z minus 4. Same thing with the x. So I look at this x plus z equals a -2. I want to solve this for x. So x is equal to a minus z plus 2. And now we're putting this thing together. I want my x is a minus z plus 2. I want my y, which is z minus 4. And I want my z, which is just z. Z is as z does. Okay. So I don't know if it's good news or bad news, but with technology, I think these will probably be the longest sort of matrix problems that you'll have to do, right? Going back and writing these lines, solving these variables for terms of z, right? So just remember you're doing things in x, y, z, and everything should have a z in it. There should be no other variable. And we look up the next one, 5. So number 5, I want to write a matrix for this thing. I write a matrix 1, 2, 6, 5. And I have what, minus 1, 1, minus 2, 3, 1, minus 4, minus 2, 1. Okay, so I do want to show you a little trick that the TIs will do. So let's go and do this one in a TI right quick. So share my screen. Let's go back to my TI Smart View. There we go. And I want to clear everything. There we go. Clear everything. Let's go to the second matrix. Let's edit the matrix so that we can put in this matrix of 1, 2, 6. And 5. Minus, go to, I have to do, not subtract 1, I have to do a negative 1. There we go. Negative 1, 1. And I want to do a negative 2. And 3, 1, and a negative 4, and a negative 2, and 1, 1, and 1, 4, 6, 1. There we go. Okay, so here I have my matrix. I have it typed all in. I don't want to mess with this anymore. I want to quit out of this. So second quit. I quit out of this thing. I want to do row reduced echelon form on this thing. So I do second matrix. I scroll on over to math to get down to row reduced echelon form. I want to do row reduced echelon form on my A matrix, which is second matrix. It's in the A. Ooh, we have this thing. Okay. So if you see something like this, typically we don't want decimals. There is a quick sort of way to convert from like decimal to fraction in TIs. And the way to do it is math. And a lot of calculators will have this to convert from decimal to fraction. So math, frac right there. And it will give us in a nice pretty fraction. So we can write this thing out as a fraction. On this one, you might notice, I don't want to give away too much. Let's write this down right quick. So 0, 1, 4/3, 0, 0, 0, 1. So we got this thing. Let's go back to our paper. And we look at this thing. We got 1, 0, 10/3. If we're looking at this, we were asked for row reduced echelon form. You might notice there's still some numbers up here. One of the reasons why that is because this is one of those special cases, right? This is one of those special cases where 0 is equal to 1. And I showed you all that extra work to get those fractions. And in all honesty, we don't actually need it here, right? And why don't we need it? Because this is no solution. This is a contradiction. And the last matrix we're going to do today. Number 6. So we're looking at number 6 right there. We want to write this thing into a matrix. So write this thing into a matrix. So what does that look like? It looks like 1, 2, 1, 4, 1, 1, minus 2, 3, minus 2, minus 3, 1, minus 7. So we have this matrix. I want you to go find some technology, go plug this thing into some technology somewhere. Okay. So what is this giving you? It should give you 105 minus 5, 2, 0, 1, 3, 1, and 0, 0, 0, 0. So now we're looking at this thing. What is this thing telling us? We want to look here at the last line. So this is giving me 0 equals 0. This means there are infinitely many solutions. There are infinitely many solutions. It's not just anything and everything. So we want to go back and write our line. So this looks like x minus 5z is equal to 2. This is y plus 3z is equal to 1. So we want to solve these two things. We want to solve these two things in terms of z. So solve this thing for x. We move this thing over. So x is equal to plus 5z plus 2. We want to move this thing over. Y is equal to minus 3z plus 1. We want to put things in x, y, z. So 5z plus 2 minus 3z plus 1. And last but not least, z is as z does. It's always over there. Z is z. And as they say in the notes, this is a line, and this is a line for any real number z. We can plug in any real number into z, and we will get that line out of there, right? Okay, so that is the last thing that we're solving here. And so I hope to see you in class soon. Thank you for sticking through. Hopefully this technology makes this a little smoother, right? All right, see y'all.